Hi gang, welcome to another fluids video. If you haven't checked out the previous ones, make sure you go back to the beginning of the playlist and start working your way through. So just a quick worked example here, an example taken from a previous question paper. So we've got ship's fuel oil storage tank contains oil to a depth of 8 meters. Very important. Calculate the thrust on a circular plate, 450 diameter, in the base of the tank due to the weight of the oil. And the relative density, the weight of the oil, is 0.8. So we're sort of introducing some bits and pieces from previous videos in this section. But as always, we're going to work our way through here, checking out our formula for thrust. All right, so when we say thrust, it's just really a force that we're calculating. So we've got force is equal to rho G A X. Alright, so we'll work our way through the question. We'll get our known values. So first of all, it contains oil to a depth of 8 meters. So X is the depth of the oil, so that is 8 meters. Okay, now the thrust acting on a circular plate. So this is where we're going to give some consideration to this dimension here. So we've got a diameter is equal to 450 millimeters. Now the observant ones amongst you will realise that this needs to be in meters. Okay, but we'll do that when we work out our radius, and the radius is required because we're going to need the area. Okay, so again, tying into some basic maths principles. So radius is equal to half of that divided by 1,000, 0.225 meters. Okay, last bit of info we've got: fuel oil's got a relative density of 0.8. So that relative density, yeah, needs to be transferred into an actual density, and we do that by multiplying that by 1,000. Okay, so that 1,000 is a constant. All right, so if you've got a relative density of 0.9, then it's always multiplied by 1,000. And if you don't know that, then go back to the first video in this series, and we'll get you up to speed with density. Okay, so we've got 1,000. So that's 800 kilogram meters cubed. Alright, so let's go ahead and solve this. So again, if you want to do a separate calculation, as I said before, if you want to do your area calculation separately, yeah, so you got area, it's a circular shape, so that's the old pi r squared, got that one. So if you want to work that out separately, by all means, crack on. Alright, but I'm going to pop it all in there because we're getting to a point where we should be able to do all that. So I'm taking my information from a list, 800 times 9.81, again, gravitational constant. If you want to make that as part of your known values, crack on with that as well. I'm going to multiply that by the area, okay, brackets, pi times radius, again, another set of brackets there just in case, alright, because we're not squaring the pi, we're just squaring the radius, okay, and that's multiplied by x, which is the height of the fluid in this case. That is 8. So force, get a big number here. So the force acting on this plate is 9.985 times 10 to the 3 newtons. Alright, so imagine I've got a tank here, yeah, it's got a plate on the bottom. That plate is got a force acting on it, and that's the way we go. Alright, so the answer to that question is force is equal to 9.985 times 10 to the 3 newtons. Alright, so again, this is followed on from previous videos. If you've skipped a couple, go back and check them out. But as always, check Canvas, get on your workbook, there's loads more examples in there. And if you want to send me a picture of any completed work you do so I can double check, or you can upload them to Canvas, then, you know, great stuff. And as always, thanks for watching, and I'll see you in the next one. Bye bye.